While synthetic division is super easy and we love it, we can only use it if we divide by a linear factor. But what about when we want to divide by a nonlinear factor? In this case, we must use long division, even if our nonlinear factor factors in to linear factors. So if you're trying to divide by a quadratic that factors, you still can't use synthetic division. You need to divide by the whole quadratic using long division. So remember about long division. So some of you may have learned different setups depending on where you're from. But if I'm taking 1,334 and dividing it by 23, well, I call this bit my dividend, and what I divide by is my divisor. My result is the quotient, and I have left over my remainder if it doesn't divide evenly. So if I was going to look at 23 going into 1,334, well, I would first look to see if 23 divides into 1, and it doesn't. It doesn't divide into 13 either, but I can put 23 into 133, and I think that's going to be about 5. Let me check and see. Hopefully that's true. So I would multiply this out. So 15 carry a 1 would give me 215. That doesn't make sense. 115. And then I would subtract this off to see what's left. So I would get 18. Obviously, if this had been bigger than 23, I could have put a 6 up here, but it's not. It's 18. 23 doesn't go into 18. So then I bring down the 4. And now I think about how many times will 23 go into 184. So I think that that's going to be about 9. So let's test that out. So then I'd get 7, carry a 2. That's too big. All right, so let's try 8. So then I'd get 4. And then we would carry a 2, and we would get exactly 184. So I now subtract, and my remainder is 0. So I can say that 1,334 divided by 23 is exactly 58. Let's see what it looks like with polynomials. So with polynomials, I have my polynomial that I'm dividing, my dividend. I divide it by the divisor, so I'm going to use that as d, and then I'd get my quotient plus the remainder, which we put over the divisor. Notice if we multiply through by the divisor, our polynomial is the same as the quotient times the divisor plus the remainder. So let's see what that looks like when we divide out. So I'm going to take 2x squared plus 3 and divide it into 8x cubed minus 4x squared plus 12x minus 8. Notice I would need to fill in zeros inside if I didn't have every single term. I don't need to fill in zeros out here. So 4x squared plus 12x minus 8. So just like when I'm thinking about dividing in with numbers, I think about 2x squared and dividing that into 8x cubed. So to turn 2x squared into 8x cubed, I would need to multiply by 4x. I'm going to line that up with the x terms. So I'm going to take 4x and multiply it by my divisor. That's going to give me 8x cubed. 4x times 3 is going to give me plus 12x. So I'm going to line up my like terms, and then I'm going to subtract. I tend to think, draw the line, change the sign to help me think about subtraction. So 8x cubed minus 8x cubed cancels. I always want that to happen. 4x squared, there's 0 here, so that's going to be minus 4x squared. I'm taking this minus 0. 12 minus 12 is 0. I'm going to bring down that minus 8. So now 2x squared times what is negative 4x squared? That's going to be minus 2. So I'll get minus 4x squared minus 6. Draw the line and subtract. So negative 8 minus negative 6 is negative 2. So negative 2 is my remainder. I can't multiply 2x squared by anything to get negative 2. I can't multiply it by anything that lines up with my terms. So what this means is that I can express 8x cubed minus 4x squared plus 12x minus 8 as the product of 2x squared plus 3 times 4x minus 2 and then a remainder of 2. So if I expanded all this out, I would get this. I could also write this as 8x cubed minus 4x squared plus 12x minus 8 over my divisor, 2x squared plus 3, and say that that's equal to 4x minus 2 times 2x squared plus 3. So these lines are equivalent lines.